Okay, so today we're going to talk about simulations. All right, so let's look at the definition up here. So simulations is the imitation of the operation of real-world process or system over time. The sampling distribution of the sample portion can be approximated by a graph of the sample portions for many different random samples. The mean of the sample portions will be approximately equal to the value of the population portion. All right, so let's look at the example here. It says, let me try to fit this in here. Okay. So we have here, a high school principal claims that 50% of the high school students walk to school in the morning. A student attempts to verify the principal's claim by taking a random sample of 30 students and asking them if they walk to school in the morning. 12 of the sampled students say they usually walk to school in the morning, given a sample portion of 12 over 30. So it's 12 kids out of the 30 of the random sample, which is equal to 0.4, which seems to dispel the principal's claim of 50%. But could the principal be correct that the portion of all students who walk to school is 50%? A simulation was done to test the principal's claim. The students completed 40 trials of a coin flipped 30 times. So they flipped the coin 30 times and they did that 40 times. Okay, so each trial, each one of the 40 trials was 30 flips of the coin. Heads represented a student walked, and the results are summarized below. So here's the sample portion. So we have 0.25, there's 1, and so on. Okay, so each one of the dots in the graph represents one of the 40 trials. So this dot here, where it says 0.25, means out of one of the trials, which is 30 flips of the coin, only 25% of the time, 25%, it was heads. Over here, you could see at about 0.48, we had 1, 2, 3, 4, 5 of the 40 trials. We had 0.4, so 48% of the time it came up that kids walked to school, or heads came up, because we're using heads to represent a walker. All right, so it says to describe the shape of the distribution. So notice the shape here looks a little like this. So it is a little skewed. It is slightly skewed to the left because of this guy over here. So we would put slightly skewed. What is the smallest sample portion observed? So the smallest sample portion would be over here. That'd be 0.25. The largest sample portion observed would be 0.65, which was over here. Estimate the center of the distribution of sample portions. So the center looks like it's about here. So it's about 0.50. All right, it says now to find the mean of the sample distribution and the standard deviation. So that you actually have to use your calculator for. All right, so if you don't have your calculator in front of you, go get your calculator. All right, we are going to put in our data. So you can use a frequency if you want, or you could just plug all these pieces of data in list 1. Whatever you want to do is fine. So go into your list, go into stat, edit, go into list. All right, so let's do 2 lists. Let's do a frequency column. So I have 0.25 in list 1, and that in list 2, that would be one of them. We have 0.35, that would be 1. We'll make this about 0.38 because it's close to 0.4, but it's not exactly in the middle. So we'll say about 0.38. And there's two of them. Or if you're putting in just in one list, then you have to put in 2.38. So you do 0.38, 0.38. And then we have 3.4. So it's either 0.4 three times, or you do 0.4 once, and then you put in the frequency column of 3. Okay, and so on. So this is about 0.43. Then we have 0.45. This one I would say is about 0.48. Then we have 0.5 here. This would be about 0.53. Then we have 0.55. This would I'd say about 0.58. Then we have 0.6 and then 0.65. So put all that data in. If you need to pause me, put me on pause so you can finish plugging that in. Okay, so when you're done, you're going to go back to Stat. You're going to go to Calc. If you use 2 columns, so you're going to use one for Stat. If you use 2 columns, you use the frequency column. Make sure you plug in L2 for frequency. If you just use 1 column and you just plug them all in all the way down, then just use L1 and to calculate that. And you get approximately the mean is approximately 0.495. And the standard deviation is approximately 0.085, sorry. Okay, so then it says, how does the mean of the sample distribution compare with the population portion of 0.5? So that would be the sample distribution. So let's write down the sample distribution is very close to 0.50. See, I have 0.495, so it's really close to 0.5. All right, recall that a student made a random sample of 30 students and found that the sample portion of the students who walked to school is 0.4. Would this have been a surprising result if the actual population portion was 0.5 as the principal claims? So 0.4 is, or 0.40 is 1 standard deviation from the mean. Therefore, it is not surprising. What do you think would happen if the sample distribution you constructed in the previous exercises had everyone in class take a random sample of the size 80 instead of 30? So you did 80 flips 40 times. What would happen? So what would happen is your results would be more accurate. So the results would be more accurate. That's accurate in there. Okay, so, and then what happens is the standard deviation is smaller. That standard deviation is smaller. Okay, which means it's given a more precise calculation. Okay, so that's it, and we'll practice some more in class tomorrow. Have a good night.